Hi, this is Jeff Hodges from Google, and we're here to talk with you today about the Web Authentication Specification Level 2 and its various enterprise features.
Hi, this is John Bradley from Yubico. I'm a senior architect and one of the people working on the web authentication and FIDO2 specifications.
So, what is WebAuthn? Also known as Web Authentication, is a web platform API that facilitates strong authentication for web applications. And we care about it because it's a replacement for username password, bringing strong phishing resistant authentication to the web. Level 2 can be regarded as version 2 of the spec. Version 1 was published in March 4th, 2019 as a W3C recommendation. Level 2 addresses some bugs that we found in the spec as we've been using it and adds some various enhancements. And if this is distributed, there's a link there to a diff. So in WebAuthn L2, otherwise known as Level 2, we have the various enhancements. We have enterprise attestation, large blob storage, app ID exclusion, cross-origin iframe support, and discoverable credentials, which can be preferred by the relying party. This is not an exhaustive list.
So one of the new features that we added in Level 2 is enterprise attestation. We got a lot of feedback after the first round of specs that a lot of enterprises are used to managing inventory on a per device level. So they want to know what the serial number of the device that they've handed out to an individual employee is, and specifically, is that device they're using actually the one I gave to that specific employee, and conform to all of my enterprise policies. So we've standardized both a new interface in WebAuthn and two different approaches at the FIDO2 CTAP 2.1 layer. The latest version of the FIDO2 transport spec is called CTAP 2.1. First one was CTAP 2. So there's two basic ways that we're approaching it. One, which is vendor facilitated, and that's when the enterprise works with their authenticator provider, and the authenticator provider pre-configures the list of relying party IDs, otherwise known, you can think of them as the websites that you're running your SSO from, for people that are using single sign-on for all of your enterprise apps. So one or more of those endpoints, depending upon how your company's organized, gets pre-configured into the authenticator and shipped to the enterprise or directly to the user, depending upon the setup. With that enabled, and the enterprise gets the serial number from the keys that are being sent out. So only if a relying party asks for an enterprise attestation in that mode, they only get it if their relying party identifier is one of the ones that's pre-configured by the enterprise and the authenticator vendor. The other mode is more for people who are using managed endpoints. If you have enterprise mobility management turned on, or other endpoint protections, say Google Apps for your Chrome browsers, you can turn on a flag which says for these given endpoints, they're allowed to ask for an enterprise attestation, and independent of what's been pre-configured into the authenticator. If you're on a managed platform, the relying party can see what the serial number of the device is, and or the public key of the attestation for that specific device. So it gives the enterprise far greater ability to manage individual devices.
Another feature is the large blob storage extension, which allows relying party to store largish, on the order of a kilobyte or so, amounts of encrypted arbitrary data with a credential. A primary use case for this is enabling web-based SSH sessions to FIDO enable web-based SSH sessions. So think SSH public key certificates being stored alongside FIDO credentials on an authenticator.
So one thing for enterprises and other parties who initially implemented U2F, the first version of the FIDO roaming authenticator protocol, they may have large numbers of credentials already registered, and a lot of the authenticators speak both CTAP1, which was formerly known as U2F, and CTAP 2.1, which we now call FIDO2. So in order to not make new credentials on devices that may have U2F credentials already created on them, we have introduced this App ID exclusion extension. So you can say, as part of your WebAuthn make credential flow, don't make a credential on this. Let me know if there's already a credential from this list of credential IDs that were created in U2F on the device. But it prevents creating duplicate extensions and confusing the user with additional credentials in their configuration for their account. There was already an extension for providing the older App ID, U2F App ID during a GET authentication. So this sort of rounds it out to provide a little bit of extra functionality on the make credential side for backwards compatibility.
And also in level 2 at the web authentication API layer, we've enabled cross-origin iframe support. This is done via what's called permissions policies, which are a feature in the web platform where an embedder can set policy on embedded frames in their web page. And this allows someone to embed a cross-origin iframe, and the cross-origin iframe is able to exercise web authentication for authentication, also known as GET, as in GET assertion only. It's for privacy reasons, we're not allowing credential creation in cross-origin iframes. We want to point out specifically that both WebAuthn Level 1 and WebAuthn Level 2 have always supported both create and get in same origin iframes. So what we're just enabling here is cross-origin support.
Right, and U2F did have cross-origin support, and we got feedback from some of the identity as a service vendors who used pop-up windows where the main login page might be the enterprise page, but the pop-up or the embedded iframe was at, say, Duo or some other identity as a service provider. And this re-enables them to, when they upgrade from U2F to WebAuthn, to enable that sort of embedded iframe service where they're providing the authentication mechanism inside of an enterprise page. So in level 2, we've added a discoverable credentials preferred. So discoverable credentials people typically think of as passwordless credentials. Now, a lot of the relying parties typically are taking a username and a password and then using WebAuthn or U2F as a second factor. This allows relying parties to start creating credentials that can be used as multi-factor passwordless credentials without forcing an error on the user and interrupting their flow if they only have an older U2F or FIDO2 authenticator that doesn't support discoverable credentials. So the RP can now ask for, rather than previously the RP had to ask for either true or false for discoverable credentials. Now they can say that they prefer a discoverable credential. So if the user's device can't create a discoverable credential, they get a non-resident credential that the RP can still happily use with the second factor flow. And now that it isn't determined up front whether the credential is going to be resident or discoverable or non-discoverable, the CredProps extension lets the relying party know for that specific credential whether it can be used in a passwordless flow. Thank you all for joining our webinar. We're going to move to a question and answer session. Hopefully we can pick up any of the things that you were unclear on during, or that we weren't clear enough in our presentation. So please get your questions ready, and Jeff and I will do our best to answer them.
Thank you, John.